All right, on lesson 610, we're working on looking at this pan balance a little bit more and trying to generate some equivalent expressions to the one that we have up here, which I wrote here. You can see a little bit better of 17x plus 22 equals 12x plus 37. And we kind of got to show the operations of how we're undoing things over here. How did I get this equivalent expression? All right, so if I look at this first pan here, I've got 17x plus 22. And when I went down to here, it changed to 17x. So I see that they got rid of the 22. So if I added 22, how do I get rid of 22? I must subtract 22 to undo that and use that inverse operation. So I'm thinking I'm subtracting 22. So if I look over here, I got to see if they did the same thing to the other side. And notice I went from 12x, it's still 12x, but now instead of plus 37, it's plus 15. So I know they did subtract 22. Because 37 minus 22 is 15. So really they're just undoing this, trying to isolate the variable, and we're trying to get x by itself eventually. So I know this actually is equivalent to this because I took 22 off both sides, it's still balanced. So what did I do in step A? The step A is this first step from here to here. I subtracted 22, and I'll just write minus 22 to show that I subtracted 22 from both sides. So we know they're still balanced because I did the same thing to both sides. Now, 17x down to 5x, so I subtracted some x's, it looks like, because I went less, and I know 17 minus 5 is 12, so it looks like I took away 12 x's. And if I look over here, did I take away 12 x's? And it looks like I did, because now I'm just down to 15, so the 12 x's are gone, because I know 12x minus 12x is nothing. So I'm just left with 15, so what did I do on both sides to keep this balanced? I subtracted 12x from both sides. And again, I'm trying to isolate that variable. So I'm left with 5x equals 15. And how do they get this to an x? They took 5x to x. So some people think, oh, they subtracted 4x, right? Which could be right. They did. 5x minus 4x is an x. But I didn't take 15 minus 4x here, okay, because I can't do that until I know x. So it looks like it might be easier to look at this side first. And if you did look at this side, remember, when you're seeing multiplying, you should think to undo that you're dividing. They're actually dividing by 5. And if I look over here, 15 divided by 5 gets me to 3. So I know they're dividing by 5. And 5x divided by 5. Remember, this is x times 5. To undo that, you divide by 5. So that gets me down to 1x. Okay, and isolates that variable. So what I did down here is I divided by 5 on both sides. And when kids miss this a lot of times, they'll think subtract 4x here. Again, you got to check that doesn't work here. You got to do the same to both sides to keep it balanced. So we know x equals 3 after I do that, and I know what x equals. All right, so all three of these are equivalent to this top one that we started with. So the most important part here, and you can't see it very well, so I moved it up here, we're supposed to substitute. So we know x equals 3. Let's plug it in and see if we're right. We always say that, plug it in, plug it in. So I'm going to rewrite this as 17 times 3. Remember, we can use parentheses to say multiply there. Plus 22 equals 12 times 3 plus 37. Again, I plugged x equals 3, so I plugged it in everywhere. And let's see if this works. Let's see if it's balanced. Okay, so 17 times 3, if I do the work there, that's 51 plus 22, which that would come up 73 when I did that. And on this side, 12 times 3 is 36 plus 37. And if I add 36 plus 37, I also get 73. So I know that x has to be 3, and I did things correctly. In this situation, x equals 3, and I proved it by substituting in. So I found what my variable equals.